Hello and welcome back to College Algebra, MAT 150. In this lecture we will be discussing the vertex of a quadratic function. So in 3.2 we discussed quadratic equations and quadratic functions. Again, to remind us, a quadratic function is a function of the form ax squared plus bx plus c. Now b and c can be whatever they want, but we usually say a is not 0. And the vertex of something like this, so again, what does a quadratic function look like? Well, it's basically this U shape. And the vertex is simply the highest or lowest point on the graph. So basically, if it's facing down, it's the top. If it's kind of cupped up, then it's the bottom. So let's take a look at two examples. So let's try to find the vertex of this function f and this function g of x. So what does f of x equal to x minus 1 squared plus 1? Well, it looks like, so we take the x, so x squared is the base, so it looks like the cup, and it's moved right 1, up 1. So we move right 1, and then up 1. So right here, 0, 0 goes to here, and then we have some base points here, and some base points here, and it looks like this, something kind of like this. Okay, not perfect, but it's the job done. So, and what is this point? Well, that's the vertex. It's in this case, it's the lowest, and it's 1, 1. All right, so the vertex is either the highest or the lowest, not both. What about g of x? So let's label this. What about g of x? Well, that's negative 2x squared plus 2. Well, x squared is the base function, again, like that. And again, we do reflections and vertical stretches first. So it would be 0, 0, and it's flipped down, and left 1 down 2, right 1 down 2. But then it's shifted up. So up 2, then left 1 down 2, right 1 down 2. And this is our function g of x. And what is this point? This is the vertex, and this is given by 0, 2. All right? So here we graphed it and we found it, but as it turns out, there's other ways to know if it's, and here it was a minimum. So so the output of the function is the minimum value. So f of x equals 1 is the minimum. So again, when we talk about minimum or maximum values, we're talking about the output. It's the minimum value. And it takes 1 to give it that minimum value, an input of 1 to get out 1. Over here, g of x, the maximum value, the sort of the furthest point up, the largest output that it has is 2. Okay, and is the maximum value. So a lot of times when we think of minimum and maximums, we think of the vertex because it's the y coordinate on the vertex. So for a given quadratic function, how can we determine if it's a minimum or if it's a maximum? So we'll find out how to determine exactly the points here in a moment. But if we want to determine if it's just a min or max, all we have to actually do is look at the a value, or the value out in front. If a is greater than 0, then it's a minimum. If a is less than 0, so negative, so positive, minimum, negative, maximum. And we can see this on display up here. Here for g of x, it was negative, and that flipped the graph over. So that's why that's the case. The negative will reflect the graph over the x-axis, and then you do everything else, and it results in a maximum. And if it's positive, it just always stays in this direction, which means you have a minimum. All right. And as it turns out, if you notice that on each side of this point, it's a mirror of itself. So on each side of the vertex, it's a mirror. So we call the x value sometimes the axis of symmetry from the vertex. right? So if you make a vertical line with the x value, so x equals whatever that number you have, you get that sort of, so x equals 1 in this case, it's an axis of symmetry. All right? And on this one, it would be x equals 0 would be an axis of symmetry. All right, and as it turns out, for quadratic functions, we have sort of two forms that we can see that frequently come up. And one of them is called the general form, and it's of the form ax squared plus bx plus c. It's the one we most often look at. The other one is of the form f of x equals a times x plus h quantity squared plus k. And that's something of the form where we complete the square. All right? And depending on which form you're looking at, so we have a's in both cases. If we bring back this one, the a in front of this one was 1. So it was positive and then thus up. So we have a's in both cases, so we can tell if it's going to be a maximum or minimum. But the way we find the vertex are given by these two formulas. So again, the vertex is a point, so we have both an x and a y. So the x is given by negative b over 2a. And then the y, since this is a function, you can just take that value and plug it into your function. So really the only part of that you have to manually compute is this, then you just plug that into whatever your given function is. And that's if it's in the general form, okay? But if it's in the standard form, that actually is much nicer. It's just the opposite sign of whatever this is for your x, and then k for your y, negative h, k. Okay, so if you're given it in this form, you don't have to do very much. And as a reminder of what I just said earlier, the maximum or minimum value of the quadratic function is simply the y-coordinate of the vertex. All right, so let's take some look at some examples. For this one, so we're going to try to find some maximum or minimum values of the following quadratic functions. So let's take a look at this first one. F of x equals x squared minus 8x. So I think this looks more of the form of the first one, the general form of a quadratic function. So we can use, so we're going to try to find the vertex, so we're going to use this formula. So x equals negative b over 2a. So again, when you're finding this, you need to use this formula, and you have to compute the x first to plug it into the y, or plug it back into the function. And in this case, what is the a and what's the b? Well, the a is the number in front of the x squared, so a is 1. And b is the number in front of the x. Don't forget the negative, so in this case it's the 8. Remember, for your a and your b, you're not including the x's, it's just the numbers. So, because, I mean, we've already solved for x here. Yeah, we don't want to double plug that in. And we plug in, so negative b, so negative of negative 8 over 2a, a is 1. So we have 8 over 2, which is 4. Then we can just take this number, so now we have a value for our x. Again, a vertex is a point, so it requires an x and a y. We take that and we plug it back in. So we take 4 and we plug it back into the original function. 4 squared minus 8 times 4. 4 squared is 16. Minus 8 times 4, that's 16 times 2 is 32. 16 minus 32 is negative 16. So we plugged in 4, got out negative 16. We found out what our x-coordinate of our vertex is. So what is the maximum or minimum value? So first off, to answer that question, the y output, so this is the x-coordinate of our vertex. This is the y-coordinate, so our coordinate would be, vertex would be 4, negative 16. All we have to do now is determine if it's a maximum or minimum value. And we determine that from the a value in front of x squared. A is 1, so since it's positive, It didn't do any flipping, so it didn't flip over, so it's still up, and that means that this is a minimum value. So negative 16 is the minimum value of the function. All right, so that's one. What about B? What if I had g of x equals 2 times x minus 3 quantity squared minus 5? Well, in that case, is this in general form or standard form? Well, looks like standard form to me. So that means since we have it in standard form, we just have to use this formula. So we don't have to do any computations. It almost comes directly out. The vertex is given by negative of whatever this is. So negative of negative 3, comma, negative 5. So we have a vertex at 3, negative 5. So when it's in standard form, it's really easy to get out the vertex. All right, and so we only have to determine if it's a minimum or maximum. And since this is positive, since a is positive, a is 2, then g of 3, so you input 3, and you get out negative 5, is the minimum value of the function. All right, so the last one, h of x. So if we have this, we have negative 3x squared minus 6x plus 5. So first off, is this in general form or standard form? Well, looks like general form to me, so we don't have that nice thing like we did in B. But what we can do is look at the A, B, and C. A is negative 3, B is negative 6, C is 5. And for the vertex formula, we need, for the general form, we need x equals negative b over 2a. But b is negative 6, so negative of negative 6 over 2 times a. A is negative 3. Negative of negative is positive, so 6 over 2 times negative 3 is negative 6. And this is negative 1. 6 divided by negative 6 is negative 1. Then we take this value and we plug it back in. H of negative 1 equals negative 3 times negative 1 squared minus 6 times negative 1 plus 5. We have negative 3 times 1. Negative 1 squared is positive 1. Negative 6 times negative 1 is positive 6 plus 5. Negative 3 times 1 is negative 3. It's an awful looking 3. There we go. 6 plus 5 is 11. And then negative 3 plus 11 is 8. Now, we know h of negative 1 is 8, and we know 8 is either a minimum or maximum. Which one is it? Well, a is negative 3, so that means that we had that flip over the, that was dealt with, that gave us a reflection. So since it's negative, that means that 8 is a maximum. So 8 is the maximum value of the function. And that concludes this lecture.